Greetings everyone. In this series of videos, what we're going to explore is a new software that I encountered this summer at an MIT workshop. It's called StarLogo Nova. Probably the best way to think of it as a three-dimensional version of Scratch. So I want to show you a couple of things that I learned this summer, how to program with StarLogo Nova. First thing I want to show you is the interface of StarLogo Nova is very similar to that of Scratch. And you have all these blocks that fit to each other like a puzzle. What I want to do is I want to show you an exploration that I learned from the creator of Geometer Sketchpad, Nick Jackiw. And I was able to replicate that in StarLogo Nova. So I want to show you what basically I call the sunflower exploration project. So here, let me just show you what we are dealing with. Imagine that I have a model of the growing of a sunflower, and we may wonder why the sunflower follows the very familiar pattern. You may be aware that the pattern of the sunflower relates intimately to the golden ratio and the Fibonacci numbers if you watch those other videos I have posted. So it'll be curious for us to understand how this works. First of all, let's understand what alternative models would have been. So I'm going to quickly show you a model in which the seeds of the sunflower are planted at every 60-degree angle. So let's imagine a model like that. So imagine that every 60-degree angle the sunflower plants some new seeds, and what you're going to notice is the plane of the sunflower is divided into 6 equal parts with a lot of clustering that is linear. There's all this wasted space, and obviously these seeds are going to compete for resources, sunlight, water, all kinds of things, and you can tell intuitively that this would not be a good configuration. So you might say, why don't we make that larger? Why don't we make a model where we are dealing with maybe partitioning the plane, the circular plane, into 12 equal pieces, and you're going to notice that this initially may look like a good idea. It probably is a better one than what we have seen before, but soon you realize partitioning the plane into 12 equal pieces ultimately doesn't lead to much better use of the space that is available. At that point, you might start wondering, well, if we divide 360 degrees evenly into a rational number of pieces, eventually this cycle is going to repeat. So why don't we try using some irrational numbers? Well, the golden ratio, as you know, is an irrational number. And observe what happens when you divide 360 degrees by the golden ratio. It leads to about, I believe, 222.5 degrees. And you notice this allows a much better utilization of space. What I'm going to do, actually, I'm going to rerun the simulation with a scarcer density so you can start seeing what is happening here and just focus on the pattern rather than so observe at every partition a new seed is planted, and initially this may look like, well, it's not doing much better. You're going to realize that the space is filling actually much more economically and much more efficiently. And as you increase the density of the seeds, this is one of the things that StarLogo would allow you to create sliders. You're going to notice when I grow the seeds according to a golden ratio based partitioning system, you really get a vastly more efficient spreading of the seeds. That way they have more space individually for sunlight and access to resources. Alrighty, one of the things that I want to show you also, one of the more beautiful things about StarLogo is it is actually 3D in nature. So I have created this model sort of bulging a little bit into the third dimension, so you can see this, and then you could also set the camera back to where you want it to be from the top bird's eye view. You could zoom in, you could zoom out. It is a great tool that allows you to run simulations and at the same time create some interesting code, varying some parameters, etc. Okay, so I hope this gives you some insight about the golden ratio, irrational numbers, partitioning 360-degree with irrational numbers, that way avoiding cyclic behavior, and why it might be beneficial in an evolutionary setting for sunflowers to use such a model. Alrighty, I hope you enjoyed it. Take care.